A rancher needs to enclose 2 adjacent rectangular corrals, one for cattle and one for sheep. If a river forms one side of the corrals and 240 yards of fencing is available, what is the largest total area that can be enclosed? Now, I like to look at it like this. All right, so here we have our river. This is our river. And we're going to just shade that in some nice dark blue here. And we're going to use that river as one side of our fence because obviously cattle and sheep must be afraid to cross the river. At least according to this problem they are. And we are going to enclose an area like this. Okay, one for cattle and one for sheep. Okay, now enclosing this pen and using the river for one of the sides, we have to find the maximum area. Okay, well, what do we know? Well, here's what I know. I'm going to call this side here the length, and I'm going to call this side here the width. Okay? And what I know is there is a total of 240 yards of fencing available. And if I look, this distance, and this distance are all equal. So I'm going to write an equation. 3W plus L equals 240 yards. Okay? So 3W plus L is 240 yards. Now, of course, what can I do with that? Well, I can very easily take this equation and solve it for either L or W. And I'm going to kind of make my life easy. Okay? And I'm going to solve this for L. Okay? I'm going to solve this for L. And so when I solve this for L, I get L equals 240 minus 3W. Okay? Why am I going to do that? Well, because this is a perimeter equation, and I am not concerned with the perimeter. I am concerned with area. So I write my equation for area. What is my equation for area? Length times width equals area. Right? And I say, well, here's the problem. I have 2 variables. I have length and I have width, and I want to find the maximum for area. So I have 2 variables. I have length and width, but what can I do? Everywhere I have length, I can substitute this quantity into the equation. So I can substitute that quantity in right there. So here's what I do. 240 minus 3W times W equals A. Everywhere you have length, you substitute this quantity right here. Okay? So you get 240 minus 3W times W equals A. Now I want to maximize my area. So what I'm going to do is I'm going to go ahead and multiply this out. And when I multiply this out, what I get is I get A equals 240W minus 3W squared. Now, what does this tell me? What does this tell me? Well, I have a quadratic whose leading term is negative. So again, if I think of this graphically, an xy axis, if I think of this graphically, what does it look like? It's going to look like a parabola pointing downward, right? And anytime you have a parabola pointing downward, because its leading term is negative, you're going to have a maximum. And you can find that maximum. Now, the way you've got this equation set up, the y value, the dependent variable, is going to be area. And the independent variable is going to be width. Okay? So if you find this x value, that is the width of the pen that will maximize the area. And then the y value is the maximum area. So we were asked to find the largest area that can be enclosed. So So how do we do that? Well, we take our quadratic here and we say, how do we solve that? How do we find this maximum point? And it's real simple. The x value for the maximum is always going to occur at negative b over 2a, which in our case is negative 240 over 2 times negative 3, which is negative 6. Okay, so negative 240 divided by negative 6 will give me 40. And in this case, it'll be 40 yards. Okay, what that means is we solve for, remember, what is x? X is the width of the pin. So that means this length, and this length all have to be 40 yards. Okay, now, how do we find the maximum? If this is the width, how do we find the maximum length? Well, you'd go back to this equation here, right? Length equals 240 minus 3w. Well, 3 times 40 is 120. So 40 yards wide and 120 yards long will give you the maximum area. Okay? Well, what is the maximum area? The maximum area is length times width. So multiply these two numbers together. So take this 120 times 40, and what do we get? 4,800 square yards. Okay? So the maximum area that we can enclose is 4,800 square yards with a width from the river of 40 yards and a length of 120 yards. So now we can tell our farmer how long to make his fence, how wide to make his fence, and the total area he can enclose. So it's a fun problem. It's a problem that applies to folks who you don't think of normally being in a math-intensive field. But it's a good way for them to maximize their fencing without spending as much on fencing, which can be very expensive. So it's a fun little problem to do, and it's a problem that's very, very common in algebra books. So if you have any questions about this or any other problem, please let me know.